Next is the mole fraction and gas stoichiometry. The mole fraction is the fraction of a particular substance in a compound. So in order to find the mole fraction, you have to divide the amount of the particular substance by the total amount. And partial pressure, PA, also equals the mole fraction times the total pressure. The question gives you the reaction of HCl synthesis, and it says that reaction goes to completion in a 6.3 liter vessel at 78 degrees Celsius, containing 2.50 moles H2 and 1.00 moles Cl2. Find the partial pressure of H2 after the reaction. So in this case, you have to do the ice chart as well. First, write the reaction. And initial change and equilibrium. Initially, you had 2.50 moles of H2 and 1.00 moles of Cl2, and none of HCl. The change would be negative x, and plus 2x, looking at the coefficients. And it also says that the reaction goes to completion. So it means that one of the reactants, the limiting reactant, has to be depleted at equilibrium. And we know that the limiting reactant has to be Cl2 because they both have the coefficient of 1 and Cl2 has a smaller initial amount. So Cl2 will be depleted at equilibrium. And now we know that x equals 1.00. So H2 will have the amount of 1.50 at equilibrium, and HCl will be 2.00 moles at equilibrium. You now know the amount of H2 at equilibrium. So you have to find the mole fraction of H2, which will be the moles of H2 over the total moles, or the total amount, which is 1.50 plus 2.00, 3.50, which equals 0.429. And then because you are looking for the partial pressure of H2 after a reaction, you have to find the total pressure first by using the ideal gas law. PV equals nRT. You're looking for pressure, which equals nRT over V. And the moles, you're using the total amount, so 3.5 times temperature, which was 78 plus 273, which is 351 over 6.3 liters. Then you get the total pressure of 16 atm. Because you know the mole fraction of H2, you can now calculate the partial pressure of H2 by using this equation. Partial pressure of a certain compound equals the mole fraction of that compound times the total pressure. Therefore, partial pressure of H2 will equal the mole fraction of H2 times the total pressure, which is 0.429, which we got over here, times the total pressure, which was 16 atm, which equals 6.9 atm. That is our answer. The last topic for today is the collection of gases over water and the calculation. So basically what's happening in this diagram is you are making a reaction happen in the water and you're collecting a gas in this tube and seeing what happens. So the question says 0.129 grams of oxygen was collected over water at 25 degrees Celsius and 1.01 atm. The collection of cylinder contained 37.45 milliliter of gas after the sample was released. The vapor pressure of water is 23.76 millimeter mercury at 25 degrees Celsius. Find the molar mass of unknown gas. In order to find the molar mass, you have to know the value for grams and the value for moles. Information over here helps you to solve the question easily. And it says that the atmospheric pressure equals the pressure total, or the total pressure of gases in the tube equals the atmospheric pressure. And the pressure total equals the pressure of collected gas plus the vapor pressure. And that is because inside this tube, there are collected gas, but also the water vapor molecules that are escaping from the liquid. So you always have to take in consideration of this vapor pressure. So pressure for collected gas equals the total pressure minus the vapor pressure, because vapor pressure is also in the tube. So in the question, you're given the vapor pressure of 23.76 milliliter mercury. So you first have to convert that into ATM. You simply can do this by dividing it by 760 milliliter mercury, which you get 3.126 E-2 ATM. That is the vapor pressure. Now you have to find the pressure for oxygen, in this case the collected gas, which is the total pressure minus the vapor pressure. And total pressure equals the atmospheric pressure, which is 1.01 ATM minus the vapor pressure we got in ATM, 3.126 E-2 ATM equals 0.98 ATM. Now it's time to use the ideal gas law to find the moles of oxygen collected. So moles of oxygen would be PV over RT according to the ideal gas law. And pressure for oxygen was calculated to be 0.98 times volume, 0.03745, because it has to be in liters and it gave you the milliliter, so you have to divide this by 1,000 over R 0.0821 times 298 Kelvin, which you get 1.5 E-3 moles. That is the moles for oxygen. You're looking for the molar mass and you have the grams and you just calculated the moles. So for molar mass, you have to divide the number of grams by the number of moles. The grams was 0.129 grams, and divide that by the number of moles, 1.5 E-3 moles. And then you finally get the answer of 86 grams per mole. And that is the molar mass, which is our answer for the unknown gas. This is the end of the video. Thank you for watching.